Well, hey everybody, Mr. East back with you. And in this video, we're going to be looking at algebraic expressions. All right, so let's just dive right in and take a look at what an algebraic expression is. So an algebraic expression is made up basically of three things, three parts that it has, three components. It has to have a variable. So a variable is a letter or a symbol used to represent an unknown or a changing value. So if you look down here at these expressions, x is a variable, w and n are variables, y is a variable. Okay, so at our point, it's going to be a letter used to represent an unknown or a changing value. Okay, the second part, the second component of an expression is a constant. And a constant is the opposite of variable. Variable means something that changes. Constant means something that doesn't change. And a constant in algebra is just another name for a number that's value does not change. All right, so in these expressions, that number 150 would be an expression. The rest of the constants here are 1. If you're going, well, I don't see a 1. Well, this x that's 1x, so we don't usually write a 1 when it's multiplied, so that would be 1x. This one would be 1w plus 1n, and this would be 150 plus 1y. So if you look down here, 3n, 3 would be the constant, 3 divided by n, 3 would be the constant as well. Okay, so basically any number in an expression is called a constant. All right, and finally, the third component of an algebraic expression is an operation. Remember, operations are things we do to numbers like adding, subtracting, multiplying, and dividing. All right, now you'll notice that in an expression, we don't use an x anymore for multiplication because x's represent variables. So the best way to write multiplication when you have an expression, all right, is, whoops, let's get this full size here, is if you have a number in front, you simply put the number in front of the variable and that shows multiplication. All right, you can also use a dot between the things you are multiplying. You also can use parentheses as well. All right, and then for division, instead of using that division symbol, we're going to write it like a fraction. Okay, so the three parts of an algebraic expression are variable, constant, and then they didn't write it here. It says right here it may also contain an operation symbol, but it will always have an operation. So I'm going to highlight right here, operation. Those are the three parts of an algebraic expression: variable, constant, and operation. All right. There's a couple more things that the textbook, by the way, this is from the 6th grade textbook, lesson 10.1 on page 263. A couple other things the book doesn't talk about that I want to bring to your attention. Something called a coefficient. All right, so this number 5 is a coefficient. If you're going, well, wait, you just told me that a number in an expression is a constant. Well, it is a constant, but when you have a number that is being multiplied by a variable, a number in front of a variable showing multiplication, we call that a coefficient. So this 3 right here is a constant. This 5 right here is a constant. The 3, though, is not a coefficient because it's not in front of a variable. It's not being multiplied by a variable. But this 5, however, would be a coefficient. All right. The coefficient tells you how many of that variable you have. So this is called 5x, but sometimes we'll say 5x's because that's what we have. We have 1x plus 2x plus 3x plus 4x plus 5x for a total of 5x's. So a coefficient is a number or a constant in front of a variable in an algebraic expression. The other thing that the book doesn't talk about is this idea of a term. All right, so an algebraic expression can be broken up into terms. Between each term will be either subtraction or addition. So this expression right here has two terms. The first term is 5x and the second term is 3. So terms in an algebraic expression are the parts of the algebraic expression that are separated by addition or subtraction. Each of those terms will be either a constant or a constant times a variable, or you can have multiple variables as well as exponents. All right, the ones we're going to be working with are pretty basic, and most of them at this point are going to have two terms. Okay? All right, there we go. So that is our quick introduction to what an algebraic expression actually is. Now, many times you're going to be given words, and you're going to be asked to write an algebraic expression for it, or maybe you're going to be given an algebraic expression and you're going to be asked to write words. So you need to know what these words are for operations. So this table might prove helpful. This is certainly not a complete table. There are other words that mean these things. But if you're looking for words that mean addition, these are words that mean addition. All right, sum, more than, plus, added to. Subtraction. All right, subtracted from, minus, difference, less than. Multiplication is there. I'm not going to read them all off. And division. Now, there's something very important that you should know. All right, addition and multiplication are commutative. All right, so addition and multiplication are what we call commutative. And what commutative means is the order does not matter, or the order may be changed. All right? So 3 plus 2 equals 2 plus 3, right? And 3 times 2 equals 2 times 3. So when you're writing an algebraic expression involving addition, the order doesn't matter. You can switch the order around. All right? Subtraction and division are not commutative. Subtraction and division are not commutative. That means order does matter, right? 3 minus 2 does not equal 2 minus 3. And 2 divided by 3 does not equal 3 divided by 2. So the order does matter. So when you're writing an expression with subtraction, you must be very careful of the order. All right? So when you see less than, that means subtract from, right? It doesn't mean subtract directly. It means subtract from. That's important. All right. So, and with division, you need to be careful. Are you dividing it by, or are you dividing it into? All right. So we'll be doing some examples of these where I will emphasize that. But just a reminder, with addition and multiplication, you could be a little more careless. Not that I want to encourage you to be careless, but the order does not matter with addition and multiplication. The order matters extremely much with subtraction and division. All right, let's look at a few examples, and then this video will be done. All right, so first, right here, write each phrase as an algebraic expression, the sum of 7 and x. So if you take a look here, sum, that is our operation word, right? So sum is right here. That is our operation word. 7 is our constant. X is our variable. All right, so what do we want to do? We want to add 7 and x. All right, 7 plus x. There we go, the sum of 7 and x. So we're translating from words to an algebraic expression. The quotient of z and 3. So quotient, again, that is our operation word. So if I look up here, quotient is our division word. Again, z is our variable. And 3 is our constant. And notice this is division, so the order matters. So I'm going to go in the order that they gave me. All right? So z divided by 3. Z divided by 3. All right. So division, you're pretty much going to be going in the order they give you, unless it says divided into, which you're not going to see as often. Divided into would say to switch the order around. All right. Okay, and then they've got a couple more here. 11x, again, when we don't put anything between them, that means 11 times x. That's what it means, okay? 11 times x, and remember 11 would be called the coefficient. Okay, x would be our variable. So one possible answer would be the product of 11 and x. The product of 11x. We could just write 11 times x or 11 multiplied by x. All right. 8 minus y, right? Again, 8 is our constant, minus is our operation, and y would be our variable. They chose to use less than. Remember, less than means subtract from or subtracted from. So you notice it says 8 minus y, but it's y less than 8, or y subtracted from 8. So that's actually 3 different ways we could translate that same expression. 8 minus y less than 8, y subtracted from 8. Those are all 3 different ways we can do that. All right. Okay then. So if we were asked to write these out real quickly here. All right, write each phrase as an algebraic expression, n times 7. All right, we could write n times 7 like that. A better way to write it would be 7n with the coefficient in front. 4 minus y, we could write 4 minus y just like that. That one's pretty much just what we want to do. 13 added to x, 13 plus x. Again, 13 is our constant, plus is our operation, or addition is our operation, x is our variable. All right, write a phrase. Okay, here we have division. So I would just say x divided by 12. All right, or we could say the quotient of x and 12. All right, we could say 12 divided into x. All right, so that last one we don't see as much divided into, but those are all correct. Notice divided into, switch the order. All right, this one down here, this is like that one we did on top. This would be 10 times y, right? Or we could say the product of 10 and y. Or we could say 10 multiplied by y. By the way, the problem said write a phrase. I'm writing 3 phrases just to show you different possibilities. It only asks for 1. All right, right here again, a lot of you might just say c plus 3. And that certainly would be okay. All right, what about c increased by 3? Or the sum of c and 3? The reason I'm trying to give you all these different possibilities is so you can learn to recognize these words and get comfortable with them. All right, you really, really need to know. It's on the previous page, isn't it? You really need to know these phrases right here. Something you really should just take to memory. All right. Okay. Diagrams. One of the things the book likes you to be able to do is to be able to solve problems and represent problems with diagrams. So if you take a look, and we've done some of these with percentages. We did these bar graphs, or these bar models rather. 7 plus x. So if you take a look right here, remember 7 is a constant. We know what that is. So there we go. 1, 2, 3, 4, 5, 6, 7. Right? 7 plus, and plus tells us we're going to put them together on the same bar. Whoops, I wanted to use green here. 7 plus, we're putting all these together, All right. What are we adding to it? We're adding x. All right. So here is x. Now, x is an unknown length. We don't know how long it should be. X could actually be shorter than one of these. Each of these represents 1. Do you guys see that? This is 1, 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 and this is x. And so what do I get? I get 7 plus x. All right? All right, what about this one? Z divided by 3. Well, again, this is 1, this is 1, and this is 1. Each of these represents 1. Now the entire length is z. We don't know how long z is. But however long z is, or whatever its value is, we're going to divide it into 3 equal parts. All right? So this represents z divided into 3 equal parts. So actually, let me take that back, because this isn't actually necessarily 1. It's one part. I apologize. So each of these is z divided by 3. It might not be 1. If z were 3, then each of these would be 1, because 3 divided by 3 would be 1. But if z were 9, 9 divided by 3 would be 3. Then each one would be 3. So it's each one of them represents 1 part. All right, here, these actually are 1s, because this part here is 7. We know that's 1, 2, 3, 4, 5, 6, 7. Here, again, that could be any number. These could be 3, 6, 9, 4, 8, 12, 1, 2, 3. They could be any value. But it's whatever it is, it's what z is divided by 3. Okay? Sorry about that little snafu there. All right, so draw a model, bar model, and then we have one more thing, and I think we're going to be done here. All right, so I'm going to go ahead and try to see if I can do this with no fill. T minus 2. All right. So this whole thing I'm going to represent as t. Okay, does that make sense? And again, it could be any length I want to. I don't know how long t is. Now inside here, I'm going to see if I could do this. 1 there. And then I'm going to try to make this one the same, make this one the same size. Again, this is a sketch, so forgive me if it's not perfect there. All right, and this is going to be 1, and this is going to be 1, and then this part that's left here is going to be t minus 2. Okay, the whole thing is t, and then these two here are 1. So this part right here, from there to there, that is t minus 2. Let me see if I can go ahead and get the eraser to work here. Can I get my eraser to work here? My eraser does not want to work. All right, let's pull this one up. I think it's going to erase too much. No, it did it. What do you know? Wow. Wow, that's awesome. And what we have here, this green part here, t minus 2. All right, so let's see here if I can highlight this. So this part right here, the green, we're going to associate green with t minus 2. All right, and this part right here, this is 1, and this is 1. So this part right here is the 2, and the whole thing, the blue part is t. All right, and then the expression, the green part is t minus 2. Does that make sense? The whole thing is t. Take away those two, and you're left with the green part. All right, 4 times y. Now what we need to remember about 4 times y is that 4 times y means, all right, when you multiply by 4, what it means is you have 4 of those things. So what this means is y plus y plus y plus y. All right, 4 times y. So I need 4 y's. So if I had something represent, here we go again. I'm going to make a rectangle, okay? So if that represents 1y, then that would represent, this is really bad, 2y. There should be a copy and paste. I bet there is a copy and paste that I could do on here. That one's a little better compared to the second one. That would represent 3y. That would represent 4y. I wonder if I can get rid of this one here. Put this one in the trash and see if I can come up with one more that's pretty darn close. Of course it doesn't come out as good as the other ones. All right, this is my last try here. All right, well, we're going to call it a sketch. Here we go. So this would be y, this would be y, this would be y, this would be y, and this whole thing would represent 4y. Does that make sense? I hope that makes sense for you. Okay, 4y, there we go. All right, and then the last thing, all right, comparing and using models. All right, it says Katriana and Andrew started the day with the same amount of money. Katriana spent $5 on lunch. Andrew spent $3 on lunch and $2 on a snack after school. Do Katriana and Andrew have the same amount of money left? All right, well, if you take a look, Katriana had X, and then she spent $5 on lunch. So X again represented the whole thing. X was the whole thing. And then right here we have 1, 2, 3, 4, 5. That's the amount that she spent on lunch. So this green part here, that's how much she has left. All right, so again, this would be $1, $2, $3, $4, $5 spent on lunch. So this is X minus 5. All right. Okay, so this is how much she started with. This is how much she had left. So start and then end. Ends the day with X minus 5. All right, so now let's take a look at Andrew. Now, Andrew, again, started with the same amount of money. Andrew had X dollars. All right. Then Andrew spent 3, and then he spent 2. So this part right here is that X minus 3 minus 2. But guys, 3 plus 2 is what? 3 plus 2 is 5. So it's actually the same as Katerina. See? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Or Katriana, not Katrina. Katriana. All right. So they actually had the same amount. So X minus 5, we would say, is equivalent to X minus 3 minus 2. Do you guys remember us talking about equivalent ratios? All right. They were ratios that had the same value. So like 3/4 and 75 over 100. Whoops, that's 75. Let's try. 3/4 would be equivalent to 75 over 100. Those were equivalent ratios. They have the same value. X minus 5 and X minus 3 minus 2. Those are also equivalent. They look different, but they have the same value. All right. Okay, I believe that's where I'm going to go ahead and stop this video. And then in my next video, I will simply work through some problems from the lesson practice with you. All right, until next time, have a great day.